Hello, this is Eric Topol from Ground Truth, and I'm really delighted to welcome today Sir John Bell, who is had an extraordinary career as a geneticist, immunologist. We'll talk about several initiatives he's been involved with during his long tenure at University of Oxford. Recently became head of the Ellison Institute of Technology in the UK. So, welcome, John.
Thanks, Eric. Thanks very much for having me.
Well, I think it's just extraordinary the contributions that you have made and continue to make to advance medicine. And I thought what we could do is get into that. I mean, what's interesting, you have had some notable migrations over your career. I think starting in Canada, at Stanford, then over as Rhodes Scholar, Oxford, and then you, of course, had a couple of decades in a very prestigious position, which, as I understand, was started in 1546 by Henry VII, the Regius Professor of Medicine at the University of Oxford. Do I have that right?
Yeah, it was actually Henry VIII, but you were close.
Oh,
So,
Henry VIII. That's right. Yeah. Okay. Good. Well, that's a pretty notable professorship. And then, of course, in recent times, you left to head up this pretty formidable new institute, which is something that's a big trend going on around the world, particularly in the US, we'll talk about. So maybe we can start with the new thing.
yeah,
Um, Tell us more about the EIT, Ellison Institute of Technology, if you will.
yeah. Um, as you know, Larry Ellison has been one of the great tech entrepreneurs, focused really on developing terrific databases over his career and through Oracle, which is the company that he founded. And Larry is really keen to try and give back something substantial to the world, which is based on science and technology. So he and I did quite a bit together over the COVID pandemic. So he and I talked a lot about what we're doing and so on. And um, he came to visit afterwards, and I think he decided that the right way to make his contributions would be to set up an institute that would be using the state of the art science and technology with a lot of AI and machine learning, but also some of the other modern tools to address the major problems in healthcare, in food security, in green energy and climate change, and in global governance. So, anyway, he launched this about 18 months ago. He approached me to ask whether I would run it. He wanted to set it up outside Oxford. And he wanted to do something which is a bit different than others. And that is his view was that we needed to try and create solutions to these problems which are commercially viable. And not all the solutions are going to be commercially viable, but where you can create those, you make them sustainable. So the idea is to make sure that we create solutions that people want to buy. And then if they buy them, you can create a sustainable solution to those issues. So we are actually a company, but we are addressing many of the same problems that the big foundations are addressing. And the big issues that you and I talk about in health, for example, are all on our list. So we're kind of optimistic as to where this will go. And Larry's supporting the project. And we're going to build out an institute here, which will have about 5,000 people in it. And will be, I think, a pretty exciting new addition to the science and technology ecosystem globally.
Well, I know the reverberations and the excitement is palpable in some of the colleagues I've spoken to, not just in England, but of course all over the world. So, congratulations on that. It was a big move for you to leave the hardcore academics. And the other thing I wanted to ask you, John, is you had distinguished your career in immunology, in genetics, type 1 diabetes, and other conditions, autoimmune conditions. And now you've really diversified, as you described, with these different areas of emphasis at the new institute. Does that is that more fun to do it, or do you have helped deputies that you can assign to things like climate change and other
Yeah.
areas?
Trust me, Eric, I'm not making any definitive decisions about areas I know nothing about. But, some part of this is about how do you set up leadership, run a team, get the right people in. And I have to say, one of the really interesting things about the Institute is we've been able to recruit some outstanding people across all those domains. So, and as you know, success is almost all dependent on people. So we're really pretty optimistic we're going to have a significant impact. And of course, we also want to take risks because there's not a lot of point in us doing stuff that everybody else is doing. So we're going to be doing some things that are, pretty way out there, and some of them will fail. So we're just going to get used to trying to make sure we get a few of them across the finish line. But the other thing is that, and you've experienced this too. You never get too old to learn, and I'm sucking up stuff that I never thought I would I would ever learn about, which is fun actually and
Oh,
really enjoyable. Yeah.
it's fantastic. I mean, you really broadened, and it's great that you have the runway to get these people on board. And I think you're having a big building that's under construction.
Yeah, we've got the original building which Larry committed to is about 330,000 square feet of space. This is completely amazing. But of course, to accommodate up to 5,000 people, we're going to need more than that. So we're looking at a much wider campus here that'll involve more than just that building. So, I think we'll end up with several million square feet of space by the time we're finished. So I mean, it's a really big project, but we've already made progress in some domains to try and get projects and, the beginnings of companies on the road to try and solve some of the big problems. So we're quite excited about it.
Now, I assume it's pretty close to Oxford, and will you have some kind of interactions that are substantial?
Yeah, so the university's been terrific about this actually, because of course most universities would say, "Well, why don't you do it inside the university and just give us the money and it'll all be fine." So, so of course Larry wasn't born yesterday, so he said, "Well, thank you very much, but I think we'll probably do, do this nearby." But the university also realizes this is a really exciting opportunity for them, and we've got a really good relationship with them. We've signed an agreement with them as to who will work where. We've agreed not to steal a lot of their staff. We're going to be bringing new people into the ecosystem. Some of the university people will spend some time with us and some time in the university, so that will help. But we're also bringing quite a few new people into the setting. So the university has been really positive, and I think one of the things that's attractive to the university, and you'll be familiar with this problem in the UK, is that we're quite good. The discovery science here is pretty good. Um, and uh, and we do startups now at scale. So, Oxford does lots of little startup companies in the biotech space and all the rest of it. But we never scale any of these companies because there isn't the depth of capital for scaling capital to get these things scaled. And so, in a way, what we're trying to do here at Ellison actually avoids that problem because, Larry knows how to scale companies, and we've got the financial support now. If we have things that are really successful, we can build the full stack solution to some of these problems. So I think the university is really intrigued as to how we might do that. We're going to have to bring some people in that know how to do that and build billion-dollar companies, but it's sufficiently attractive. We've already started to recruit some really outstanding people. So I think so as a way to change the UK system broadly, it's actually quite a good disruptive influence on the way the thing works, to try and fix some of the fundamental problems.
Yeah, I love that model, and the ability that you can go from small startups to, really transformative companies have any impact. It fits in well with the overall objectives. I can see that. The thing that also is intriguing regarding this whole effort is that in parallel, we've learned your influence. The when the UK is a genomics world leader without any question, and no coincidence that that's been your area of emphasis in your career. So we've watched these three initiatives that I think you were involved in: the UK Biobank, which has had more impact than any cohort ever assembled. Every day, there's another paper using that data that's
Yeah,
coming out.
yeah,
There's Genomes England,
yeah,
and then now Our Future Health, which a lot of people don't know about here, which is well into the 5 million people enrollment. Can you tell us about, uh, this is now 15 years ago plus when these were started, and of course now with a new one that's the biggest ever. What was your thinking and involvement, and how you built the UK to be a world leader in this space?
Yeah, so if you turn the clock back 20 years, or actually slightly more than 25 years ago, we it was clear that genomics was going to have a play. And I think many of us believed that there was going to be a genetic element to most of the major common diseases. Turned out to be true, but at the time there were a few skeptics. But it seemed to us that there was going to be a genetic story that underpinned an awful lot of human disease and medicine. And we were fortunate because in Oxford, as you know, one of my predecessors in the Regis job was Richard Dahl, and he built up this fantastic epidemiology capability in Oxford around Richard Peto, Rory Collins, and those folks. And they really knew how to do large scale epidemiology. And one of the things that they'd observed, which is turns out to be true with genetics as well, is a lot of the effects are relatively small, but they're still quite significant. So you do need large scale cohorts to understand what you're doing. And it was really Richard that pioneered the whole thinking behind that. So when we had another element in the formula, which was the ability to detect genetic variation and put that into the formula, it seemed to me that we could move into an era where you could set up again large cohorts, but build into the ability to have DNA, interrogate the DNA, in, and also ultimately interrogate things like proteomics and metabolomics, which were just in their infancy at that stage. So very early on, I got together because I was at that stage the Nuffield Chair of Medicine, and I got together Rory and Richard and a couple of others, and we talked a little bit about what it would look like, and we agreed that 500,000 people, late to middle age, 45 and above, would probably over time, when you did the power calculations, give you a pretty good insight in most of the major diseases. And then it was really a question of collecting them and storing the samples. So so in order to get it funded, I at the time I was on the council of the MRC, and George Rada, who you may remember was quite a distinguished NMR physiologist here. He was the chief executive of the MRC. So I approached him and I said, "Look, George, this would be a great thing for us to do in the UK because we have all the clinical records of these people going back for a decade, and we'll continue to do that." And so, of course, we immediately sent it out to a peer review committee in the MRC, who completely trashed the idea and said, "You got to be joking." So I thought, okay,
It'll be good, right?
there's a lesson. And I did say to George, I said, that must mean this is a really good idea because if it had gone straight through peer review, you would have known you were toast. So anyway, I think we had him one more swing at peer review and decided in the end that wasn't going to work. So George, and in the end, George, to his credit, took it to MRC Council, and we pitched it, and everybody thought, "What a great idea! Let's just get on and do it." And then the Wellcome came in. Mark Walport was at the Wellcome at the time, great guy, and did a really good job at bringing the Wellcome on board. And so, like people forget the quantum of money we had to do this at the time was about 60 million pounds. I mean, it was it was it was astonishingly small. So, and then of course we had a couple of wise people who came in to give us advice. And the first thing they said, well, if you ever thought you were really going to be able to do genetics on 500,000 people, forget it. That'll never work. So I thought, okay, I just mark that one out. And then they said, and by the way, you shouldn't assume you can get any data from the health service because you'll never be able to collect clinical data on any of these people. So I said, yeah, yeah, okay, I get it. Just give us the money and let us get on. So anyway, it's quite an interesting story because it does show how conservative the community actually is for new ideas. We we then I I I chaired the first science committee, and we decided about a year into it that we really needed a chief executive. So we got Rory Collins to lead it, and he's done it. I sat on the board then for the next 10 years. But look, it was a great success. And as you say, it is kind of the paradigm for now large global cohorts, genetic epidemiology cohorts. So then, as you know, I advised government for many years, and David Cameron had just been elected as prime minister. This was in about 2010, and at the time, I'd been tracking because we had quite a strong genomics program in the Wellcome Trust Center, which I'd set up in the university, and we were really interested in the genetics of common disease, and it became clear that the price of sequencing, and Illumina was now the clear leader in the sequencing space. But it was also clear that Illumina was making significant advances in the price of sequencing because, as you remember, the days when it cost $5,000 to do a genome.
Oh, yeah.
Anyway, it became clear that they actually had technology that gets you down to a much more sensible price, something like $500 a genome. So I approached David and I said, we're now pretty sure that for many of the rare diseases that you see in clinical practice, there is a genetic answer that can be detected if you sequenced a whole genome. So why don't we set something up in the NHS to provide what was essentially the beginnings of a clinical service to help the parents of kids with various disabilities work out what's going on, what's wrong with their children. And David had a child with Ohtahara syndrome, which, as you know, is again. And so David was he said, "Oh God, I'll tell you the story about how awful it was for me and for my wife, Samantha." And, nobody could tell us anything about what was going on. And, we weren't looking for a cure, but it would have really helped if somebody said, "We know what it is. We know what the cause is. We'll chip away and maybe there will be something we can do, but at least you know the answer." So anyway, he gave us very strong support and said to the NHS, "Can you please get on and do it?" Again, massive resistance, Eric, as you can imagine. All the clinical geneticists said, "Oh my God, what are they doing? It's a complete disaster." Da, 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 da. So anyway, we put on our tin hats and went out and got the thing going. And again, they did a really good job. They got to their 100,000. The idea was to get 100,000 genomes done in a reasonable time frame. I think 5 years we set ourselves. And the technology advanced. People often underestimate the parallel development of technology, which is
Yeah.
always going on. And so that really enabled us to get that done. And it still continues. They're doing a big neonatal program at the moment, which is really exciting. And then I was asked by Theresa May to build a life sciences strategy because the UK, we do this stuff, not as big and broad as America, but as for a small country, we do life sciences pretty well. So I'd written
That's an understatement, by the way, a big understatement. Yeah.
anyway. I wrote the strategies in 2017 for Theresa about what we would do as a nation to support life sciences. And it was interesting because I brought a group of pharma companies together to say, "Look, this is for you guys. So tell us what you want done." We had a series of meetings, and what became clear is that they were really interested in where healthcare was going to end up in the next 20 years. And they said, "You guys should try and get ahead of that wave." And so we agreed that one of the domains that really hadn't been explored properly was the whole concept of prevention,
Yeah.
early diagnosis and prevention, which they were smart enough to realize that the kind of current paradigm of treating everybody in the last 6 months of life, you can make money doing that. There's no doubt, but it doesn't really fix the problem. And so they said, "Look, we would love it if you created a cohort from the age of 18 that was big enough that we could actually track the trajectories of people with these diseases, identify them at a pre-symptomatic stage, intervene with preventative therapies, diagnose diseases earlier, and see if we could fundamentally change the whole approach to public health." So we anyway went back and did this numbers because, of course, it's a much wider age group. A lot of people don't get it all sick, but we thought if we collected 5 million people, we would probably have enough. That's 10% of the UK population, adult population. So anyway, amazingly, the government said, "Off you go." We then had COVID, which, as you know, was kept you and I busy for a few years before we could get back to it. But then we got at it, and we hired a great guy by the name of Rajiv Ali, who had done a bit of this in the UAE, and he came across, and we set up a population health recruitment structure, which was community based. And we rapidly started to recruit people. So we've now got 2.9 million people registered,
It's incredible.
2.3
Yeah.
people consented, and we've got blood in the bank and all the necessary data, including questionnaire data, for 1.5 million people growing up. So we will get to 5 million, and it's amazing. So
It is. It
um,
really is. And I'm just blown away by the progress you've made. And what was interesting too, besides, you all weren't complacent about, oh, we got this UK biobank, and you just kept forging ahead. And by the way, I really share this importance of finally what has been a fantasy of primary prevention,
yeah,
which was
yeah,
never really achieved. It's always, oh, after a heart attack, then you
exactly.
know. But
Exactly.
that's what I wrote about in the Super Agers book, and I'll get you a copy. But the
No,
whole
I know you're a passionate believer in this, and
yeah.
we need to do a lot of things. So we need to work out, what's the trial protocol for primary prevention. We need to get the regulators on board. We got to get them to understand that we need diagnostics that define risk, not disease, because that's going to be a key bit of what we're going to try and do. And we need to understand that for a lot of these diseases, you have to intervene quite early to flatten that morbidity curve. So
Yeah, absolutely. And what we've learned, for example, from the UK Biobank is not just, of course, the genomics that you touched on, but the proteomics,
yeah, yeah,
the organ clocks, and all these other layers of data. So that gets me to my next topic, which I know you're all over it, which is AI.
yeah,
So when I did the NHS review back in
yeah.
2018, 2019, the group of people, which were amazing, that I had to work with, no doubt why the UK punches well beyond its weight. I had about 50 people, and they just said, "You know what? Yeah, we are the world leaders in genomics. We want to be the world leader in AI." Now, these days, you only hear about US and China, which is ridiculous. And you have perhaps one of the, I would say, most formidable groups there with Demis and
Yeah,
Google DeepMind.
completely, completely.
It's just extraordinary. So, all the things that the main foci of um, the Ellison Institute intersect with AI.
They do. And we've got 2 underpinning platforms. Well, actually 3 underpinning platforms that go across all those domains. Larry was really keen that we became a real leader in AI. So he's funded that with a massive compute capacity. And remember, most universities these days have a hard time competing on compute because it's
Oh
expensive.
yeah, yeah.
So that is a real advantage to us. He's also funded a great team. We've recruited some people from Demis's shop who are obviously outstanding, but also others from around Europe. So we've recruited now about 15 really outstanding machine learning and AI people. And of course, we're now thinking about the other asset that the UK's got, and particularly in the healthcare space, is data. So we do have some really unique data sets because those are the 3 bits of this that you need if you're going to make this work. So we're pretty excited about that as an underpinning bit of the whole Ellison Institute strategy is to fundamentally underpin it with very strong AI. Then the second platform is generative biology or synthetic biology because this is a field which is sort of I hesitate to say limped along, but it's lacked a real focus. But the we've been able to recruit Jason Chin from the LMB in Cambridge, and he is one of the real dramatic innovators in that space. And we see there's a real opportunity now to synthesize large bits of DNA, introduce them into cells, microbes, use it for a whole variety of different purposes, try and transform plants at a level that people haven't done before. So with AI and synthetic biology, we think we can feed all the main domains above us. And that's another exciting concept to what we're trying to do. But your report on AI was a bit of a turning point for the UK because you did point out to us that we did have a massive opportunity if we got our
Oh
skates on.
yeah, yeah.
And we
Just
do have talent. But you can't just do it with talent these days. You need compute and you need data. So we're trying to assemble those things. So we think we'll be a big addition to that globally, hopefully.
Yeah, well, that's another reason why I'm so excited to talk to you and know more about this Ellison Institute, just because it's unique. I mean, there are other institutes, as you know,
Yep.
like Zuckerberg,
Yep. Yep.
the ARC Institute. This is kind of a worldwide trend that we're seeing where, great philanthropy investments are being seen outside of government, um, but none have the computing resources that are being made available, nor the ability to recruit, the AI scientists that'll help drive this forward. Now, the last topic I want to get into with you today is one that is where you're, really grounded in, and that's the immune
Yeah.
response.
Yeah.
So it's pretty darn clear now that, well, in medicine, we have nothing. We have the white cell neutrophil to lymphocyte ratio. What a joke. And then on the other hand, we can do T and B cell sequencing repertoires, and we can do all this stuff, right? Autoantibody screens, and yeah, the list goes on and on. And how are we ever going to make a big dent in health where we know the immune system is such a vital part of this without becoming, ability to check one's immune status at any point in time in a comprehensive way? What are your thoughts about that?
Yeah. So I mean, you seem to be reading my mind, Eric. And we need to recruit you over here because I mean, this is one of our big projects that we've got that we're leaning into, and that is that, and we all experienced in COVID the ins and outs of vaccines, what works, what doesn't work. But what became very clear is that we don't really know anything about vaccines. We have no, we basically you put something together and you hope the trial works. You got no intermediate steps. So we're building a really substantial immunophenotyping capability that will start to interrogate the different arms of the immune response at a molecular level so that we can use a combination of human challenge models. So we've got a big human challenge model facility here, use human challenge models with pathogens and with associated vaccines to try and interrogate which bits of the immune response are responsible for protection or therapy of particular immunologically mediated diseases or infectious diseases. And a crucial bit to that, and one of the reasons people have tried this before, but first of all, the depth at which you can interrogate the immune system has changed a lot recently,
Oh,
and I think
yeah.
you can get a lot more data. But secondly, this is again where the AI becomes important because it isn't going to be as simple, oh, it's the T cells. It's going to be, well, it's a bit of the T cells, but it's also a bit of the innate immune response. And don't forget mate cells and don't forget a bit of this and that. So we think that if we can assemble the right data set from these structured environments, we can start to predict and anticipate which type of immune response you need to stimulate, both for therapy and for protection against disease. And hopefully that will actually uh, create a whole scientific foundation for vaccine development, but also other kinds of immune therapy and things like cancer and potentially autoimmune disease as well. So we're so that's a big push for us. We're just busy. The lab isn't set up. We've got somebody to run the lab now. We've got the human challenge model set up with Andy Pollard and colleagues. So we're building that out, and within 6 months, I think we'll be starting to collect data. So I'm just kind of hoping we can get the immune system in a bit more structured because you're absolutely right. It's a bit pin the tail on the donkey at the moment. You have no idea what's actually causing what. So no, it's
Yeah, well, I didn't know about your efforts there, and I applaud that because it seems to me, the big missing,
yeah,
the hole in the whole story about how we get advanced human health. And with the recent breakthroughs
yeah,
in the lupus and these various autoimmune diseases by just targeting C19
yeah.
B cells and resetting, like a control alt delete of their immune system, is just very
It's amazing.
extraordinary.
No, it's amazing. And you wouldn't have predicted a lot of this stuff. And I think that means that we haven't really got under the skin of the mechanistic events here, and we need to do more to try and get there. So, but there's steady advance in this field. So I'm pretty optimistic we'll make some headway in this space over the course of the next few years. So we're really excited about that. It's an important piece of the puzzle.
Yeah, well, I am really impressed that you got all the bases covered here, and what a really exhilarating chance to kind of peek at what you're doing there, and we're going to be following it. I know I'm going to be following it very closely because I know, like all the other things that you've been involved with in your colleagues, big impact stuff. You don't take little swings here. The last thing, maybe to get your comment. We're in a state of profound disruption here, where science is getting gutted by
Yeah.
a madman and his henchmen, whatever you want to call it, which is really obviously very serious state. I'm hoping this is a short term hit, but I'm worried that the this will have a long, perhaps profound. Any words of encouragement that we're going to get through this from the other side of the pond?
Well, I think regardless of the tariffs, the scientific community are a global community. And, I think we need to remember that because, our mission is a global mission and we need to lean into that together. First of all, America is such a powerhouse of everything that's been done scientifically, in the human health domain, but not only that, but across all the other domains that we work in. We can't really make the kind of progress that we need to without America being part of the agenda. So first of all, a lot of sympathy for you and your colleagues because I know it must be massively destabilizing for you
Yes,
not to
yes.
be confident that the things that work are there to help you. But I'm pretty confident that this will settle down. Most of the science is all the science is really for public good. And I think the public recognizes it and they'll notice if it's not being prosecuted in the way that it has to be. And the global science community cannot survive without you. So we're leaning in behind you. And I hope it will settle. I hope that the tail, one of my worries is that, these things take years to set up and literally hours or minutes to destroy. So, if we can't afford to take years to set them back up again. So we do need to be a bit careful about that. But I still have huge confidence in what you guys can achieve and we're all behind you.
Well, that's really helpful, getting some words of wisdom from you there, John. So this has been just terrific. Thanks so much for joining. This is, getting your perspective on what you're doing, what's important is so essential. And we'll stay tuned for
Yeah.
sure.
And come and visit us at the EIT, Eric. We'd be glad to see you.